Hello students, myself Dr. Divya, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. In this session, we will discuss the methods for the green synthesis as a part of green chemistry and fuels. So here are the topics, methods for the green synthesis from the green chemistry. So in that, we will discuss phase transfer catalyst. This is a method wherein we use phase transfer catalyst for the reactions. So what are the theories of catalysis? Then mechanism of phase transfer catalysis reaction. Then applications of this phase transfer catalyst reactions wherever the applications are found. Then advantages and limitations of this procedure or the method. So if you see the phase transfer catalyst, what is a phase transfer catalyst? It is a kind of catalyst that facilitates the transfer of one reacting species from one phase, for example, aqueous phase, to another phase like organic phase. It is like transferring the reactant from one phase to another phase, from this phase to this phase, or in the vice versa way, in order to carry out a reaction. So that will help in carrying out a reaction. Why we really require this? Because many chemical reactants, for example, there are reactions wherein we use reactant A and B reactants. So what happens to these? They do not react. Why? They sometimes do not react, can't collide due to separation of these species by an interface. So if A is soluble in aqueous phase, if for example this is soluble in water and this is soluble in organic solvent, so they both are immiscible in nature. So what happens then? The reaction does not take place. So such problems have been solved by using a type of catalyst known as phase transfer catalyst. It is also called as PTC in short. So there are different types of catalysis theories. So the catalysis reaction takes place in different ways. So there are two ways, like intermediate compound formation theory, homogeneous catalyst reaction, also called homogeneous catalyst reaction, or adsorption theory or heterogeneous catalyst reaction. So most of the reactions depends on only these two forms of catalysis reactions. So what happens in the intermediate compound formulation? According to this theory, one of the reactant combines with the catalyst to form an intermediate product which carries out the reaction. So what happens here? The catalyst will react with one of the reactant, forming a intermediate product, that is C. If C is the catalyst, A is the reactant, it forms AC, which is nothing but intermediate product. So what happened to this intermediate product? It will be obviously unstable. So this unstable intermediate product will react with reactant B. So this B on reaction will give our desired product. So this is the desired product, and the catalyst is again back to the reaction. So it will go on for the next reaction. This is how the reaction takes place in this theory of intermediate compound formulation theory. So the next theory is the adsorption theory. So what happens here? Heterogeneous catalyst reaction. Why we are calling this heterogeneous catalyst reaction? In general, adsorption theory applies to heterogeneous catalytic reactions. This reaction, the catalyst functions by the adsorption of the reactant molecule on its surface. For example, this is the catalyst. So if this is the catalyst and these are the reactants, what is happening here? It is just adsorbing the surface of catalyst. So this occurs in four different steps. So what happens in the first step? Adsorption of reactant molecule A or B adsorbs on catalyst. So the reactant molecule A and B strike the surface of catalyst. So strikes the surface of catalyst. So it just sits on the catalyst surface. The reaction molecules held up by partial chemical bond. Adsorption is done by only partial chemical bond. So next happens the formation of intermediate complex. Nothing but, as we have seen in the homogeneous reaction, similarly it happens, but the only thing is adsorption. Adsorption takes place here. So the reactant molecule adjacent one another join to form an intermediate complex AB. Intermediate complex AB. So this intermediate is unstable. So whenever A and B are adsorbing to catalyst surface, this is the catalyst, and for the surface it is adsorbing. So what happens? It forms an intermediate with one of the reactant. It forms a partially bonded intermediate complex with both the reactants. So this is obviously unstable. Then what happens? Decomposition of this intermediate complex. This intermediate complex breaks to form the products C and D. So this catalyst is therefore helping the reactants to come together and react. So what happens? Upon breaking the bond, it will form product C and D. Product C and D. This is how it forms the product. The product molecules hold to the catalyst surface by partial chemical bond. So if you see this figure, it is having a chemical bond again with the catalyst surface. So it is partially chemical bond. So ultimately it has to form a product. So then what happens? Release of product should take place. So the product particles are released from the surface. Eventually, after the formation of these products, the partial chemical bond will break and release these products. So ultimately forming products C and D. So these are the theories where it involves the formation of products. So there are different types of phase transfer catalysts. So these plays an important role in forming the products. So there are different types, like two types of phase transfer catalyst. One is quaternary ammonium or phosphonium salts, like inorganic salts, benzyl triethyl ammonium chloride, inorganic salt, and chrome ethers and tryptans. So these are two different types of phase transfer catalysts. So what happens? These catalysts have somewhat slightly different actions, but effects are same. Ultimately, the effect is same. Only the bonding may vary or the reaction mechanism may vary. However, the effect is same, like it will favor the formation of products within very less time with immiscible solvents. Both types transfer the anions from one phase to another phase and allow them to be free to react with the substrate. So both of them will help in reaction and forming the products from different phases. So these are two different types of phase catalysts. So quaternary ammonium salts such as ammonium, phosphonium, antimonium and tertiary sulfonium salts. So some of the examples of these quaternary salts are also called as ammonium salts are ammonium, phosphonium, antimonium, tertiary sulfonium salts. So these will combine with organic or inorganic reactants present and gives the reaction, ultimately gives the products. So the commonly used one are aliquot 336, that is methyl trioctyl ammonium chloride. So these are the examples for phase transfer catalysts. Or benzyl trimethyl ammonium chloride or bromide. So this X is halide. Halide can be anything like chloride or bromide. Then benzyl triethyl ammonium chloride. Triethyl ammonium chloride. This is again halide compound. Then cetyl trimethyl ammonium chloride or bromide. So this N is nothing but the ammonium group, then trimethyl ammonium chloride or bromide. X can be either chloride or bromide. So in this way we use different phase transfer catalysts. So there are different types of phase transfer reactions. So liquid-liquid phase transfer, for example, organic phase, organic phase and aqueous phase. So of these, it can be either both of them can be liquid or a solid or liquid, solid or liquid, solid or liquid phase transfer, solid or gas phase transfer, or triphase catalyst. Depending on the application, we use different catalysts. So some of them are immobilized ammonium and phosphonium salts, insolubilized chrome ethers and cryptans, insolubilized co-solvents. So these are different catalysts that we use for different types of reactions. So the most important mechanism is that this heterogeneous catalyst, which is used mostly to solubilize the salts that are insoluble in organic phase solvent. So whenever there is some insolubility in the reactants in the particular solvent, this phase transfer catalyst helps in solubilizing. So the phase transfer catalyst facilitates the migration of reactants. So reactants should either migrate to an aqueous to organic or organic to aqueous in order to reaction takes place. So it helps in migration of reactants from one phase to another phase where reaction occurs. So by using PTC or phase transfer catalyst, one can achieve faster reactions, obtained higher yield by convection of products. So make less byproducts. It will give less byproducts to eliminate the need of expensive and dangerous solvents. So it will help in avoiding any expensive solvents and also reduces the formation of many byproducts. So that is very good in nature. Like for reaction to take place, it will obviously take less time as well, reduce the byproducts. That is what we require for any manufacturing or production plant. So PTC is especially need for green chemistry. So therefore, this is a part of green chemistry and its synthesis methods. So as we have seen there schematically previously, this is the organic phase and aqueous phase. On reaction with phase transfer catalyst forms the product and releases the very less byproducts or very low byproducts. So this is how it will help. It will help in giving the better products in no time. So for example, quaternary ammonium salts like benzyl trimethyl ammonium chloride, phosphonium salts like hexadecyl tributyl phosphonium bromide and chrome ethers. So these are examples. So one of the example is the aqueous sodium cyanide solution. Reaction with 1-bromo-octane does not react readily. The reaction does not occur readily due to poor stability of 1-bromo-octane. So this has poor stability in aqueous phase. In aqueous phase, it is not stable. So what happens if it is not stable? Its form is not stable, so keep on changing. So the reaction does not take place very rigorously. So then by addition of small amount of hexadecyl tributyl phosphonium bromide, one of the PTC, a rapid reaction occurs to give nonyl nitrile. So we need to react these both, but at normal conditions the reaction is not taking place. But when this is added, tributyl hexyl decyl tributyl phosphonium bromide. This, upon adding, is giving a product nonyl nitrile, and this is some byproduct. So it is the reaction is favoring because of phase transfer catalyst. So the stability is also achieved for the reactant so that the reaction will takes place. So we will see some of the examples how these reactions are going on and how the applications are. So applications of these PTC reactions, nitriles from alkyl halides. So formation of nitriles from alkyl halides in the presence of PTC or phase transfer catalyst. So for example, if we take organic halide and react with sodium cyanide in aqueous, it forms nitrile only in the presence of PTC or phase transfer catalyst. So one of the example is benzoyl cyanides from benzoyl chloride. Benzoyl chloride, this is the benzene ring and the chloride with sodium cyanide in the presence of a phase transfer catalyst is forming benzoyl cyanide and sodium chloride. So this is also soluble. So this has no issues at all. So the formation of benzoyl cyanide is rapid in reaction in the presence of PTC. PTC is helping a rapid reaction and giving the benzoyl cyanide product. Then is the aryl ethers or thioethers. So in this case, phenol on reaction with alkyl halide in the presence of aqueous media and a phase transfer catalyst is forming aryl ether. So benzoin condensation wherein benzaldehyde in the presence of ethanol and water and the cyanide is forming benzoin, and the yield is 92%, which is good yield. So the reaction is also rapid. Reaction is also rapid for the formation of benzoin from the benzaldehyde. Then is the esterification. So the carboxylic acids can be esterified with alkyl halides in the presence of triethylamine. So carboxylic acid as sodium salt. As a sodium salt in the react with alkyl halide in the presence of PTC and gives esters in the presence of PTC or phase transfer catalyst. This is mainly used in the field of pharmaceuticals like synthesis of various drugs like dicyclomine, phenopyridine, oxylidine, Ritalin. So these are some of the drugs where we use this type of reactions forming esters. Then other example is the Williamson ether synthesis, wherein alcohol and alkyl halide react together forming ether, Williams synthesis ether. So, and the byproduct is forming along with this. So, if we take the same using the PTC reactions, we will see in detail what the mechanism takes place. So, for example, 1-chlorooctane, when it is reacting with sodium cyanide, forms two layers because organic layer, this is organic layer, this is aqueous layer. So, if we take a separating funnel, there is organic layer and aqueous layer. So there are two different layers forming. So upon heating, even after heating this reaction mixture under reflex vigorously for 1-2 days. 1-2 days also there is no reaction. So normally without PTC, no reaction even for 1-2 days. for this reaction. But what happens when we add PTC or phase transfer catalyst like quaternary ammonium salt, tetrahexyl ammonium chloride is used, wherein this 1-chlorooctane and sodium cyanide reacts in the presence of tetrahexyl ammonium chloride and gives the product nearly in 2 to 3 hours. 2 to 3 hours only. So 1-2 days also there is no reaction. However, when we add a quaternary ammonium salt as a PTC catalyst, it is giving 100% yield in 2 to 3 hours. So what's happening in this reaction? Let us see. In this process, the ammonium salt catalyst transfers the cyanide. So cyanide into organic phase. So there are two phases forming. For example, organic phase and aqueous phase. So what happens? The cyanide will be transferred from aqueous. So this is sodium cyanide. The cyanide will be transferred to organic phase. Transfer of cyanide to organic phase. So this will activates the transferred cyanide for the reaction with alkyl halide. So here we have alkyl halide in the organic phase. So this will react with cyanide that is being transferred from the aqueous phase. So transfers the displaced chloride ions back to the aqueous phase to start the new catalytic cycle. So whatever halide is present will be transferred back into the aqueous phase for the reaction to proceed. So this is how it will help. The two immiscible solutions, whenever they are used, the phase transfer catalyst will help a lot to favor the reaction, transferring one of the anions to other phase so that the reaction would takes place. So that is a main concept we have to remember, like it is transferring the cyanide, which is an anion that is present in the aqueous phase, will be transferred to the organic phase where the reaction takes place with the alkyl halide. So that is how it will help in the reaction. So for example, it occurs in 2 steps. This process occurs in 2 steps. First is the intrinsic reaction or organic phase displacement step, wherein if in case there is an intrinsic reaction that is taking place or the organic phase that is there will be displaced or the ions present in the organic phase will be changing. So what happens there? If this is the rate determining step, then it is called as extraction mechanism. So the mechanism will be changing. So the rate of reaction or the rate determining step is very important. If this reaction is dominating, that forms the rate determining step. So that will give us to extraction mechanism. It will follow the extraction mechanism. In case this transfer step, second is the transfer step. Transferring an anion from one phase to another phase takes place. If this is the rate determining step, then it is interfacial mechanism. We just need to remember that it is changing from one phase to another phase. So it is called as interfacial mechanism. So same thing is given here. Like if it's alkyl halide with quaternary ammonium salt is changing the interface at the interface from the aqueous phase, it is sending the cyanide to the organic phase. So if this is the reaction, it will form interfacial mechanism. Interfacial mechanism. Okay, so this is the interface between organic and aqueous phases. So the cyanide that is present in aqueous phase is transferring to the organic phase. So it is giving a reaction that will help, that will favor the products. So that is how it is. Or there is another method wherein the chloride that is present in the organic phase will be moving to the aqueous phase. So these are the 2 steps that is taking place and favors the reaction. So for example, if quaternary salt extracted from the aqueous, if the salt is extracted from the aqueous phase then it is stark. If we see here, this is the organic phase and this is the aqueous phase. So what's happening here? The quaternary ammonium salt is reacting with the cyanide and the alkyl halide, forming the cyanide product, and again the ammonium chloride. So this will again go back to the organic phase. So there is extraction of these organic or quaternary salt from the aqueous phase. So this is one type of reaction that will take place, and the other type of reaction is quaternary salt stay outside the aqueous. So it is near the interface that is taking place, and the other one is the quaternary salt stay outside the aqueous phase. So this is the aqueous phase, but there is the quaternary salt that is present outside the aqueous phase. So in this mechanism, this is how it forms and is also called as McCusker. So they have proposed this theory or the mechanism. So in both them, both transfer mechanisms are correct. So both of them are correct, may takes place, but depends on the size of quaternary cations. So the cations present plays an important role. The size of the cation plays an important role, with the first being for the small to medium. Small to medium size cations will takes place. So these reaction will takes place when the cations are small to medium sized, and the second will takes place when medium to large size cations. So this is how the mechanism may vary. Ultimately, they both give the products. So depending on the application and the reaction, we use different types of quaternary ammonium salts with different sizes of cation size. So therefore, there are two different mechanisms that will take place. So there are reactions that are going on. So what are the effects of some variables or the reaction procedure? Like whatever we are applying during reaction may affect, like stirring, temperature and solvents that we use can affect these reactions. So we will see how they will be affecting. So agitation, which is nothing but stirring, influence only the transfer rate. The rate of transfer is only affected by the agitation because the stirring is taking place. So agitation speed should be high enough so that it has no influence on the overall reaction. So it is a simple logic, like stirring will affect only if it is slow because there is no proper mixing of that both these solvents. So it has to be very high enough so that it has no influence on the reaction rate. Then concentration of water also depends. Then with anions, difficult to transfer having saturated aqueous solutions. Saturated solutions drives the equilibrium towards catalyst substrate complex. It is nothing but if, for example, anions that are present whenever they are difficult to transfer. So they will be, some anions will be difficult because they are in saturated state, because these salts are saturated. So that will it will help the reaction rate, because it will it will favor the reaction towards catalyst substrate complex, that is, it will stabilize there. So it will not favor the reaction towards product. Also, minimal amounts of water reduces hydration of ions. So whenever there is water scare, also there is less amounts of water, the hydration of ions takes place and will stabilize the reaction. It will stop the reaction, so it will not move ahead for the reaction to take place for forming the products. So these are the important things we have to consider. They look very simple, but we need to consider these, that appropriate amount of water and the concentration maintains throughout the reaction. Then organic solvents, use of organic solvents can influence intrinsic reaction rate. This also affects the interfacial tension. So for example, if there are two phases organic and aqueous phase. So this is the interface. So the interface will be affected by this organic solvent, because in most of the cases the immiscibility takes place only when there are organic and aqueous solvents present for that particular reaction. So whenever there is an interface forming between these two phases, there is tension that is forming between these two phases at the boundary. So this boundary will affect the rate of reaction or the transfer rate. So CH2Cl2 is mostly used or extensively used because it dissolves most quaternary salts and also hydrophobic. So we are using quaternary ammonium salts. So these are mostly dissolved in CH2Cl2. So they are mostly used extensively, and also because of its hydrophobicity. So for asymmetric PTC, non-polar solvents such as toluene are used extensively because they maximize interactions between two counterions. So toluene is also used most widely as a non-polar solvent because it will increase the interaction between counterions or the reactants. So this will increase the interactions, therefore it will increase the product formation. Next comes the temperature. Temperature will affect the intrinsic reaction rate. So this wherein most quaternary ammonium salts decomposes at high temperatures. For example, 50 to 70 degrees for systems containing KOH. So these quaternary ammonium salts, whenever they are used, must be used in temperatures where they are stable. Like for example, they are decomposing above 50 to 70 degrees centigrade. Therefore, it will favor the reaction at lower temperatures. Next is the co-catalyst. It can influence both intrinsic step and transfer step. As we have seen, there are two steps that is going on. So intrinsic step and transfer step, so both will be affected by the co-catalyst, because a catalyst plays an important role in this transfer reaction. So if there is a co-catalyst, it will more affect. So therefore two steps are affected. Often used to help one of the two steps. This co-catalyst is added to the reaction only when there is a requirement that one of the step has to be favored. So we are adding to help the second step to move ahead. For example, addition of alcohols, particularly diols, significantly increase the ease of hydration and hydroxide. So hydroxide anion transfer. So this alcohol, whenever we are adding alcohols like diols, it will increase the hydroxide anion formation or transfer. So hydroxide will be forming easily and will be transferred. Therefore, the miscibility occurs and the reaction takes place. Catalyst. This is the most important part, which is the main part of these reactions. So the size, the shape affects the anion activation or intrinsic rate reaction, and the bulkiness can slow the rate of reaction. Bulkiness will slow the rate of reaction. So ability to solubilize the aqueous phase reagent into organic phase. So it should have the ability to it should help in solubilizing the aqueous phase reagent into organic. So next comes the advantages. So we have discussed a lot of reactions and the effects that are due to the variables, the conditions that we are imparting during reaction. So what are the advantages? It does not require vigorous conditions and reactions are fast. So we already have discussed that at high temperatures the quaternary salts will itself decompose. So we will be using low temperatures or the ambient room temperatures only. So it does not require vigorous conditions, and also reactions are fast. It do not require expensive aprotic solvents. So solvents also, the expensive solvents can be avoided because in simple organic and aqueous phases, the catalyst is favoring or helping in solubilizing or dissolving the reactant so that it will go into the reaction and favor the product. So they do not require high temperatures. The reaction occur at low temperatures. So the catalyst itself is unstable at high temperatures. So therefore it will favor low temperature reactions. There is no need for anhydrous condition since water is one of the solvent. Water is one of the solvent. Anhydrous condition, maintenance of anhydrous condition is very tough in different seasonal conditions also. So since water is used here as an aqueous phase, this obviously does not require any anhydrous conditions for salts, either salts or the reactants. With the help of PTC, the anion is available in organic solvent and so its nucleophilicity increases. So the anion is making, the catalyst is making favorable for the availability of this anion in the organic solvent so that the reaction will take place. So next comes the limitations. So what are the limitations or drawbacks? So this catalyst may have some limitations like ordinary tetraalkyl quaternary salts decompose at high temperatures. So this decomposing at high temperatures sometimes will be a limitation because there are some reactions that would require high temperatures. So that is greater than 120 to 149 degree centigrade. 120 to 149 degree centigrade. At these high temperatures, if there are any reactions, we cannot perform using this phase catalyst, phase transfer catalyst mechanisms. Even at low temperatures, under highly alkaline conditions, these catalysts decomposes. So even alkalinity at pH greater than 7 is also basic, then basic or alkaline will affect the catalyst property. It will decompose. So even at low temperatures, if we are using pH is also very important to maintain. These salts undergo decomposition in the presence of highly nucleophilic anions such as phenoxide. So there are some decompositions that are going on because of presence of nucleophilic anions such as phenoxide. So we have to take utmost care in deciding the reaction before we move ahead. Then chrome ethers and tryptans are stable under the conditions but are more expensive than quaternary ammonium salts. So even there is decompositions that are taking place. There are other phase transfer catalysts like chrome ethers and tryptans that can be used, but they are expensive. They are expensive than the simple quaternary ammonium salts or phosphonium salts. So we have to consider the cost before we initiate that reaction. So for the transfer of divalent or trivalent anions, no superior catalyst has been introduced. So if a single if there is a divalent or trivalent anions present, then there are no other catalysts that are available for this transfer into other phase. One of the disadvantage of chrome ether catalyst is that it is limited by hole size relationship. For example, 15 chrome 5 has a hole size similar to sodium cation diameter, is selective for sodium ion over other cations. So these are some of the disadvantages. Chrome ethers, there is chrome forming and it has a cation inside this chrome. So this has similar size or similar size of sodium ion diameter. So we generally prefer sodium ion over other cations when this is the case. So it will also affect the other cations present in that particular solvent or reaction. So this is how the phase transfer catalyst takes place and their advantages and limitations and applications. So we will discuss the next method in the next session. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.